Monday to Friday. 9 a.m. till 12 p.m. This is Today with Kino Kamis
on Cape Talk.
Coming up, you're going to be hearing Dr. Chris Smith, the naked scientist, a.k.a. Dr. Friday. So he'll be coming up. And a quick voice note from you. We played a bit of music as well, and we got some response to that. And I think it's important just to get some of your feedback on that. I must be honest with you. You know, traditionally we used to say, rock's for white people and R&B's for black people. It doesn't work like that anymore. But the one thing I do see is a lot of R&B and this normal pop nonsense that a lot of radio stations play. And that's fine, and there's a market for it. But if you're on the coast, there's nothing better than some good classic and with a mixture of contemporary rock and maybe a little bit of, good R&B in the mix as well. But we don't have radio stations like that, and I dream of radio stations like that.
Wow, Kino, lekker, that little cut of music. Oh, man, give us more of that.
Hey, man. And the one we were playing, Chris, by the way, is Dire Straits' Money for Nothing. And that guitar riff. It's just absolutely unbelievable. How are you doing?
Yeah, I'm really good, and I was loving that little bit there. Could have listened to that for a lot longer. I think your true calling in the long term is you have to start that network and go and get that coastal radio network up and running.
I'm going to need a really intelligent DJ in the UK, by the way.
You'll be looking for a very long time. Look elsewhere. No, I'll come and join your radio station. I love Dire Straits, actually. Unfortunately, I never got to see them in concert. I was always hoping I would. I went to see Pink Floyd a few times because my dad got me into Pink Floyd, and then I got into kind of progressive rock kind of music. So I went trailing around after all the prog people for a while, and then they've all got old, so you can't go and see gigs with them very much anymore because they're not really touring anymore. But when no one's going to concerts at the moment, are they? Funnily enough, so that's a bit of a shame.
Exactly.
Although there's a bit of movement here in the UK. We've got Boris Johnson saying we're easing our lockdown a bit more this week, so that's a kind of plus point, while simultaneously shutting off connections with France and other bits of Europe, including the Netherlands and Spain, putting people who are coming back from there into quarantine. And now New Zealand is out of the blocks with, they've broken their 102-day stretch of no local COVID cases with a big surge in Auckland, so it's all kicking off again.
That certainly is. What is it about music and, riffs and things that really make us feel good? How does the body actually respond to that? I thought I'd ask you a rather door.
Well, I think the reason is simply that sound plays an important part in our communications. Of course, you devote a lot of your brain territory to decoding sounds and noises because that's what speech is. And your body also has very significant amount of movement wired into it, because obviously when we're deciding to run or jump or walk, this is something that we do with a rhythm. And because you put one foot forward, the other foot forward, and when you run, it's a repeated rhythm. And therefore, probably given that we know that there are links in the brain between what one bit of the brain's doing or another bit's doing, sometimes if you map a sound onto a movement, you want the two to go in sync. And this is basically how birds work. For example, they sing in harmonies, they sing together. We sing in choirs together. We walk together. Armies march together. And so it's syncing a marching band, for example. It's syncing sounds and movement with repeated movements. And I think probably that's why we like music. We like the predictability of music. We learn the music. We like the understanding and the emotions that it summons up in us with the pictures it makes us form in our mind, but it also makes us want to dance. And I think all those things come together and bond as an audience. And I think that's why mass gatherings work, because it's people all getting together doing the same thing in sync. And it's something we've evolved, as have many animals, to do. And that's why we find it pleasurable.
Indeed. Jeff in Glencairn Heights. Good morning, sir.
Good morning.
Hello.
I'd just like to know why, with older people, I'm in my 70s, younger people can stand on one leg and close their eyes. Older people, as soon as you stand on one leg and close your eyes, you want to fall over. Why is that?
That's an interesting question.
There's a range of reasons for this, okay, and it's probably not just one single reason. One of them is that contrary to what we all kid ourselves, not everything improves with age. And balance is one of those things that does not improve with age, because when you think about what does standing on one leg involve, it involves muscle strength, because in order to keep yourself stable, you've got to have enough muscle strength in that one limb and have muscles and joints that will move fluidly and in an agile way in order to correct for the moment-to-moment imbalances. Because when you're balancing on one leg, you're continuously changing your muscle tone in different directions and redistributing your tone of your muscles all over your body to change the position of your body slightly to keep yourself standing up straight. So you need muscles that can respond fast, and you need joints that can move easily so that you can respond quickly enough so that you don't then topple over. You also need a system to detect movements that you're making so you can correct for them. And this is your vestibular system in your ears. And this detects any minute movements and produces righting or compensatory movements in your muscles that keep you balanced so that you can stay standing up. This becomes less acute and less effective with age. And also, if you keep your eyes open, it can help, because looking at a distant target also gives additional feedback about movements of your head. And because your head is the longest distance from your feet when you're standing upright, the movement of your head is much greater than the movements further down your body. So your head can detect those movements much sooner and relay that information again to muscles that can make compensatory movements. But as we get older, vision isn't so good. And also, some of these reflexes are less robust than they were when we're young. So I think a range of factors play a role in meaning that we're just a bit less strong and resilient when we're a bit older and more likely to topple over. And this is why older people are more prone to injuries from falls and breaking their hips, for example. So it's understanding that we suffer from these sorts of consequences as we get older, but it's not a given. And there are some people who are, in their 80s and are still very strong and still very, very good at doing these sorts of things. It'll come down really to how fit you were to start with and how active you stay. And the best way to make yourself good at these sorts of things is to take regular exercise up to what's comfortable and what you can achieve, because this will keep your muscles strong and that will hopefully prevent you from toppling over if you did find yourself needing to stand on one leg.
Wonderful question. Thank you very much for putting it to us. Let's go to Barry in Pinelands. Hi, Barry.
Hi, good morning to you, Keno. Good morning to you, Chris.
Hi there.
Chris, just something that's been I've been mulling around in my head is the virus comes and goes in different formats. Obviously, it's been various viruses have been around for a long, long time, but they always seem to come back and mutate themselves where where antibiotics are not effective on them, which to me would mean that there's some sort of brain cell in there that they're actually mutating themselves. How do they mutate themselves to become antibiotic resistant?
Yes, okay. Well, remember that viruses don't respond to antibiotics, bacteria do. So viruses are a totally different entity. Viruses are nothing more than an infectious bag of genes that need a cell, whether that's a bacterial cell, and yes, bacteria can catch a cold and get a virus just like our cells can, or whether it's a virus that's preying on one of our cells. Bacteria are quite different. They are their own living, breathing entities. They are cells in their own right, and they grow sort of similar to the way that our cells grow. But resistance against drugs can affect both bacteria and viruses, and I'll explain how that happens. And the most normal way it happens is if you've got something, let's take a bacterium as an example, that's growing incredibly fast. If you've got a ferocious rate of growth, you're producing thousands of new bacteria in a second. Every time you copy the genetic information in a bacterial cell or a virus, then there is a small chance, and in some organisms an even bigger chance, for various reasons, that it will make a genetic spelling mistake. This is rare with DNA, but it's not zero. And therefore, if you're making enormous numbers of progeny, offspring, then the potential to have made a genetic spelling mistake, a mutation, is that bit higher. And just occasionally, by chance, if you make a genetic spelling mistake in a crucial gene that actually is targeted in some way or whose function is affected by a drug, then there is a chance that that change in that gene, which results in some kind of function in the bacterium, changing in a way that the drug will no longer work, just increased. And because bacteria and viruses grow at such a ferocious rate, they're rolling the dice many, many times. And therefore they have the potential to find in amongst their milieu. And if you've got a big group of bacteria, there are millions of bacterial cells there. there is a higher likelihood with those sorts of numbers that you will find an organism that has made the right sorts of genetic spelling mistakes to give itself an advantage against that drug. And if you've got a huge population of bacteria that are all susceptible to a drug, and then a small number that become a bit resistant, pretty quickly the population is going to become dominated by those bacteria that are a bit resistant. And then from those a bit resistant bacteria, you will start to select others that make more spelling mistakes, more genetic mutations that give them an even bigger advantage against that drug. And quite quickly you've selected for a population which are a subpopulation of the original population that just by chance had this advantage. Now it's a major advantage for them and they become all of the population. And this is basically natural selection. And it works against viruses, it works with bacteria. There's no knowledge, it's purely a numbers game, and the bacteria growing because those with the advantage conferred by a genetic mutation do much better, have more offspring, and therefore pass that genetic change into more other organisms, so you get more of them. And that's how it happens.
And we go to Ingrid. Ingrid's in Bloberg. Ingrid, I'm worried about you. Poisonous plants. Are you married? Just checking.
Yes, I am. I've got a plan for my future. I saw the movie White Oleander, didn't I?
Good to have you on. Chris is listening.
So the question is, I've got in a pot, I planted an oleander, and then afterwards, in my wisdom, I planted a Cape gooseberry. Now, I know that sometimes plants that grow close, well, I understand that, for example, if oats grows close to grain, there can be gluten contamination through the root system or something.
Oh, I haven't come across that. I'm not certain about that, because these are big proteins, and I would be surprised if they can pass a big protein like that from one plant to another. I've not heard that, to be honest with you.
All right, then that must be misinformation. But with regard to the oleander, will it not affect the Cape gooseberry in a negative way? I can eat the Cape gooseberry if I plant it first.
Yeah,
I'm not aware that plants are actually passing big things amongst themselves, but plants definitely have a conversation in the soil. And this has become more apparent in recent years. People have done studies where they have put radioactive chemicals into, say, a tree. So you can feed a tree with radioactive carbon dioxide, and it's not harmful, the radiation. It's naturally occurring carbon-14. And you can then trace where that signal goes through into other trees. And you know that you've only exposed one particular plant or tree to your radio label, but you can see it then turn up in many other trees thereabouts. And the route it takes is to go literally through the roots. So the trees pull in the radioactive carbon dioxide, they use photosynthesis to turn it into sugars. Those sugars go down into the roots, and in some instances, the roots of two trees will touch each other and they can actually pass messages backwards and forwards. In other circumstances, there is in the soil, as well as tree and plant roots, a huge network of fungi. And these fungi form an underground switchboard, as it's called. And fungi can get things and find things and make things that plants can't. But plants can make stuff that fungi can't. And so there is a subsoil trading market going on where fungi snuggle up to the roots of plants, and the plants give as payment some sugars that they know how to make. And the fungi pay for the sugars by surrendering some other chemicals that they know how to make or scavenge. And plants will actually go to the fungus that gives them the best deal. So if a fungus tries to rip off a plant and it takes the sugar and doesn't give much in return, the plant won't deal with that fungus in future. It's very diplomatic, very democratic. It's very unlike South African past political leaders, funnily enough. But this is extraordinary. Well, that's true. And so what this enables is the interplant, interspecies communication via this subsoil network, in some cases root to root, in other cases via an intermediary, like a fungal conduit, as it were. But the kinds of molecules that are being exchanged, they tend to be smaller molecules. I don't think enormous, great macromolecules like proteins are going across this way, but I might be wrong. And if anyone knows better, do let me know. Yep. But there are some plants that will do bad things to a particular patch where they live in order to give their own offspring the best fighting chance. And acers do this. But I'm not aware that plants, just that the kind of thing will grow in the garden, are going to wipe out other things near them in that sort of way. So I think probably that your plants will be quite happy in the garden together. But as I say, if anyone knows better about the exchange of these really big molecules, not just small ones, do let me know. I'd be fascinated to hear. But this is an amazing area that we're only just beginning to scratch the surface of how plants talk to each other under the soil like this.
Absolutely. Ingrid, great question, but to be safe, keep them far enough apart at least.
Okay, and I can't make this plan. I have to make another plan.
Ingrid in Bloberg, lovely call. I wish your name was Jack. His name is Jaco and he's in Parow. If your name was Jack, I could have called you Jack Parow. Good morning, Jaco, how's it?
Good morning, very, very well. Thank you, guys. Good morning, everyone. I'm going to try to express my question with the limited English I've got. But listen, I bought my first telescope 2 weeks ago, and when I looked at the stars last night, I was just in awe. And I was thinking about the star Betelgeuse. A few months ago, you guys spoke about it, that it is dying and it should go supernova. And so my question is this. If we look at the stars, we look into history, and I think Betelgeuse is about 700 light years from us. So the star we see tonight is 700 years, the light is 700 years old. So if Betelgeuse goes supernova, will we see that supernova only in 700 years from now, or would our sensors on Earth and telescopes pick it up?
Well, the answer is that you're quite right that the light that's coming to us from these stars, because the stars are so distant, the light that's arriving here has taken, in some cases, billions of years to get to us. And so if a distant star is a certain number of light years away, what that means is that a light beam leaving that object today will arrive the distance that we are from that object in that number of years' time. So if something is, for the sake of argument, 700 light years away, it means that the light that's now arriving and reaching us here left that body 700 years ago. So it is a fact that some of the things we are seeing in the night sky, when we look heavenwards and we see stars, that light is already billions of years old. That light has been travelling to us. If you see a smudge in a distant galaxy, some of those distant galaxies may be billions of light years away. And stars in our own Milky Way, there are stars 100,000 light years away. The Milky Way is 100,000 light years across. So therefore there are stars in our own galaxy where their light left that star 100,000 years ago. There were ancient human ancestors wandering around on Earth when that star spat out those rays of light, which have been travelling through space for all those hundreds of thousands of years before they got to us, which boggles my mind in some way. So yes, when you see those distant starlights, you are looking back in time.
Wonderful. Great question, Jaco.
Thanks.
Thank you very much for it. And Home Affairs will happily change your name to Jack, eh? That's Jaco. Let's quickly take a voice note. You've sent in the voice notes, and then we'll go to Gordon. Let's first take a listen to the voice note.
A question for Dr. Chris. Please, 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 this could be life-saving. I have planted a Cape gooseberry with a magnolia.
Okay, no. Sorry, that's not meant. That question
and
was
I know that
asked. Joe, thank you very much. Let's go to Gordon. You answered that one. Sorry about that. Gordon in Constantia. How are you doing, Gordon?
Strong and you.
Always good, sir. Thank you for asking.
Good. Question for the naked scientist. Early morning, the Earth is rotating towards the east and Venus appears to rise above the horizon. I've lain awake watching this a couple of times, and I've noticed that there appears to be an optical illusion of the rate of ascent through the atmosphere of Venus soon after it rises above the horizon, compared with when it's later on near its zenith. And I wondered if you could explain this optical illusion. And given that the light is passing through much more atmosphere closer to the horizon, it seems inconceivable that the rate of ascent appears to be faster when it's near the horizon than when it's closer to the zenith.
I think, Gordon, that this is very similar to the moon illusion. We talk about the moon on the horizon illusion, which is when you see the moon very low in the sky, the moon looks a lot bigger than when the moon is higher up in the sky. And actually, this is the wrong way round, because when the moon is high up in the sky, it's actually coming through a lot less atmosphere to reach us than when the moon is on the horizon, where it's got to traverse a greater distance through the atmosphere of the light coming to us for us to see it. So why the difference? And psychologists attribute this effect to the fact that when you see the moon close to the ground, you are seeing it in relation to other objects on the ground, and therefore they act as a form of reference point, and your brain says, well, I know the moon is a long way away, and it's a big thing, and I know how big a house is, so therefore this thing, which is a long way away, must be absolutely enormous, because look how big this house is, and it makes the moon appear to your psychology bigger than it is. But once the moon has risen sufficiently, then you haven't got anything else to compare it with, and it's a single eye, a sort of body in an empty sky, and so it looks smaller. Now, it may well be that what's happening with your observation of Venus, and I haven't seen this for myself, so I can't say whether or not this is a fact or not, but I'm going to speculate it's very similar. That when you've got Venus rising above the horizon, it may well be that you've got this pinpoint of light, and your brain is attributing more importance to it, and more relevance and salience to it, making it appear to be moving in a greater, more prominent way than when it's higher in the sky and you've got fewer reference points to compare it with. Just a speculation. But if anyone knows better, do let me know.
Absolutely. Gordon, thank you very much for that, and have a fabulous weekend, sir.
Thank you.
That's Gordon in Constantia. Chris, no more time for any more questions, because then we'll run into news and Petrus will bring out the big whip. But as always, great chatting to you, and you must have a wonderful... What's your plan this weekend, by the way?
Well, this weekend I'm on medical duty at the hospital, so my plan is I'm going to have a great weekend on call. Isn't that fabulous? Don't you wish you could be me?
By the way, when you're on call, do people know who you are? Do they? Hey, this is the Naked Scientist, and then do they start asking
Sometimes.
you
It is quite funny, because obviously at the moment with coronavirus, I'm on the telly quite a lot. And so these people ring up, and then they get through to me, and then they say, hang on a minute, don't I know you? And then you think, oh God, do they think I'm someone they don't want to know? And you have to sort of make that momentary decision as to whether or not to fess up. But yes, it is quite funny sometimes.
Chris, have a wonderful one. Love to the family. Always great chatting.
All right then, take care, Kino. Bye-bye.